Okay guys, so tonight I'm actually doing something that's a little bit different. I'm kind of just playing around and experimenting based off of a shorts video that I had put up about torquing spark plugs. So it kind of just had my mind going because of some of the comments on there. Some people were saying they almost don't believe the fact that you have to, or why, or some comments to the point saying I've never torqued spark plugs and so on and so forth. So I just wanted to make this to try to help clarify a little bit more as to why they are recommending to torque the spark plugs on gas direct injected engines. That's the fuel injection type where the injector is in the chamber. And it's important on where the spark plug is clocked, basically indexed, to be able to get a good combustion. I think more specifically in the lower idle portion. Also because they can run a very lean mixture at the some of the idle portions, so it's very critical as to where the spark plug is going to face. As far as where specifically they want it facing, that I do not know 100%. So I am here playing around, trying to see what we both, you and I, can learn on this. So what I have here to begin with are both BMW engines, cylinder heads. That's off of an N55. It's an inline 6-cylinder direct injection. This is its smaller brother. It's a 4-cylinder N20, same style injection system. And then here what I have is 3 used spark plugs that I have in my spare bin. And I wanted to show and or explain a little bit about these. Again, we are all here to learn. This middle one, you can clearly see, came from the factory or the dealer. It's a Bosch, and the number is ZR5TPP33-S. So keep that in mind. Next, we'll move to this one. It's an NGK OEM also. Just this one is not labeled with BMW, but the number is the one for BMW. Let's see, so SILZK8, or no, that's a B, R8D8S. So this is another one that is used for BMW or listed as OEM. This one clearly is OE. This one here is part supplier, also listed as OE. Clearly it's a Bosch, and the number is, let's see, so ZR5TPP33. Now if you remember this one, it's the same exact number minus the dash S. I believe this one had an S at the end. I'm not sure if that's part of what BMW is doing. I'd have to look at the breakdown of the nomenclature for the numbers. I have a list for NGK, but this one here, again, you can, I mean, it's listed to be able to be used, but look at the portion there. That I measured it, it's about a millimeter difference between the two. And then if you look at the NGK, it's the shorter style also. Now the post that I had made was that you have to torque them dry with no lube, because the size of the shank with the thread pitch or number of threads at a specific torque number will clock your plug or ground strap at a certain point. So almost like mathematically, you can't go wrong by the size and the thread and the torque. It should put them at a certain point relatively close all the time. And I must tell you, there is some leeway on the torque. The torque spec is 23 Newton meters, and they give you a variance, I think, of plus or minus 3. So, not sure where that can put things, but so the point is to find out at where these 3 different ones will land, and also on one of them I am testing with lube, basically NICs. And that's what I have here in off camera. This is when I started playing around. I've got this to hopefully do it on camera and get similar results, because I was surprised on this. So I've got them listed so we don't get confused. This is this guy here. I have him on cylinders 1 and 4. The factory Bosch one is on number 2, and the NGK that's listed as OEM is on number 3. Obviously, I torqued them all to the same 23 Newton meter with a good torque wrench, and this is where they landed. Now you can tell this, for reference point, this is the injector hole. This is where this landed. I made a mark. This one landed here, made a mark. This one landed here, made a mark. This one, which is going to be the same style as this, so it should land relatively close as to where this one did. But this one I have NICs, and look at where it landed. Way, way off. That one was surprising to me. So that's the differences that I got with these spark plugs. So there's a lot going on, and the reason why I'm doing this, because I did run into this. I had a friend of mine helping me. I ordered him a bunch of what I was hoping to be the correct Bosch, installed them. He had a bunch of misfires. Obviously it wasn't doing that beforehand, and took them out, put these NGKs, and it ran fine. This was years ago, before I was truly aware of the potential issue that incorrectly clocked plugs can do. So ever since then, and finding out in literature form with service information the importance of that to avoid issues, I always go ahead and try to get the correct one and always torque it. And just to show how they do protrude into the chamber, that's that first one. There's the other one. Here's the NGK. I think this one comes out the furthest, but it also clocks the closest to full facing the injector, and obviously that one comes in the way it does. So for next, what I want to do is do the same thing to show you guys on this, on camera, torquing, and just again for my curiosity, for repeatability and seeing how things come in as far as their indexing. So we'll get them installed, torqued, and see what we get. And also to try to make things as equal or even across the board, I'm going to clean the threads of the first 4. We'll use the first 4 cylinders, and get the threads all fully good clean. We'll do the same with the plugs, and we'll do the same, the last one we'll do with NICs. Okay, so I got the threads cleaned, and this is the way I'm gonna go. I'm pretty much gonna go the same way, just for keeping the confusion down. So 1, 2, 3, 4. I'm gonna add a fifth just for giggles. I'm gonna impact it in with threads that weren't fully cleaned, just to see where it lands, if people are doing this by just impacting them in. We'll go ahead and try to get this set up. And we'll get started. So first one is the non-OE Bosch. Next is the BMW OEM. Third one, the NGK. Next is, we'll put some NICs on this one. Nothing too crazy, but just something, just to see what it does. So there we go. And lastly will be the one, again, the non-OE Bosch, but we will just impact it in. We'll start with that. There is the torque spec. For now, I'm going to do them all the same. Maybe curious to see what more or less we'll clock them at. But let's just see this first. And number 4, the one with lube. Alright, so moment of truth. So there's cylinder 1, cylinder 2, cylinder 3, cylinder 4, and cylinder 5. And now for this one. So cylinder number 1, this is the non-OE Bosch, pretty much perpendicular. So, and on this one, I'm measuring from here, not the injector side. So it's 90. The OE, the BMW Bosch, this way to here was 50. The NGK one from here to here was at 45. The non-OE Bosch with lube was from here to here at 70. And then the impacted one was from on this end at 60. So the two that were consistent, pretty much almost the same, was BMW Bosch and then the NGK one. They're pretty much facing the same way. This one, these two surprisingly were kind of similar, about 10 degrees off, but a little bit similar. And this one again, fully perpendicular. As far as where they want them to land, again, I don't know 100%. The only thing is I can try to install correct ones at the torque and visually see, and I think that's what I'm seeing here as far as consistency. What's odd to me is, and all manufacturers are different, and it all also depends on many other factors like the chamber design, the angle of the injector, angle of the plug, the piston top and the design of the top of the piston. As far as, I guess, how and where and why they want to index it. But Mercedes on their literature have, I believe, the whole open side facing the injector. This one, with the two that are more consistent, it's almost like, let's call it, their backs towards the injector. But is this all 100%? No. It's just me messing around trying to figure out, and also form a demonstration and or visual display of what happens when you torque or don't torque, or add lube or impact, so on and so forth. Correct plug, incorrect plug. Because again, look, we have, let's call it quadrants. The two that are supposedly for this application are on this quadrant, and then the rest are on this quadrant. So again, application of plug per engine can also determine things. So they're facing totally different ways. So it's just things to keep in mind. So I did just want to get on here and show you the torque spec from BMW. Again, it says ungreased, so no lube. The thread size we have is the M12, so it's 23 plus minus 3 Newton meters. Quickly, just wanted to get some service information literature just to help prove out a point, the importance of this. Again, this is a topic that I decided to kind of mess around with due to the fact that some people seem to be, I won't call them non-believers, but again, almost as if they are thinking that it's not too critical. So, of course, they're telling you that it's important. Again, here that it's essential to adhere. Tightening torque influences the position of the spark plug. And then here on the diagram, they're making it, they pictured it facing the injector. Whether how true that is, not sure. Here they're telling you again also about OEM and not true OEM and the thread deal. This is when the NGK and the factory owned were both torqued to 23, which is actually what we just saw BMW call for, and the difference in location at that same torque due to let's call it incorrect application, kind of like what we saw with the ones here. There's the injector. So, and they go as far as telling you potential engine damage due to the looks like burning of the fueling in the incorrect way can cause piston melting. And again, this is part of BMW's information. So they tell you that the spark plug geometrically must lie directly in the fuel injection trajectory. To do this, precisely 23 Newton meters must be observed during installation. As the spark plug electrode is positioned particularly deep inside the combustion chamber, they're able to run a lean air fuel mixture, can also be ignited. So that's part of, I think that's part of how you can cause some damage because of how lean they run, and if it's positioned wrong at those speeds and temperatures and mixtures, you can cause potential mechanical engine damage from just the heat that can build up at those lean mixtures. And again, they're not telling us where exactly that ground strap should be. I know that they say the spark plug must lie directly in the fuel injection trajectory, but they're just literally saying the spark plug, not the open face area of it. So they're telling you info without telling you fully what they want. Again, it's more of, I guess, us trying to find out by first-hand experience. So at this point, I think I'm just gonna mess around with different torque ratings on each cylinder just to see where that puts us in relation to the 23 Newton meters. So cylinder 1, I will go at 20 Newton meters. So number 2 will go 26. Number 3, I'll go to 30. Now number 4, since it's the one with lube, I'm not too sure how important that one's going to be, so I'm just going something crazy at real low, 15 Newton meters. And the last one is it's a dry one. I'm going to go, let's go 40. We have someone that's going to really crank down on it without knowing if they treat it like an old school spark plug. Actually, sorry, that's 35. Again, we'll do, again, 40. So, again. Okay, so here are the, I guess, results of the different torque applications that I was doing. So the first two were the within spec of the plus minus 3 Newton meters, and it landed pretty much right where it was for that one, and the same here. So all in all, I would say that's at least true. Not worrying about the type of plug right now, is we're using the same ones in there, just different by plus minus 3 Newton meters. As far as the spec of what they tell you and where they're wanting it, the plus minus 3 will still get you in the same area of the 23 right on spec. So that's kind of cool to see. Again, as far as where they want to locate it, we don't know 100%, but that was one that supposedly calls for this application. Again, we're reiterating. This one was the over torque. This one was the over torque. This one again with lube kind of, and it went really light on torque. So not too important, but it did make some sort of difference between the initial one and second one. But what I wanted to point out, this one had a noticeable difference there between the two, which basically went from 45, 55. So there was a 10-degree difference, and then on this one, again, a noticeable difference, and again, it went to 50. So surprisingly, another 10-degree difference. So with over torquing to 40, over torquing to 30, and I'm wondering how much more can it increase by higher torque application, meaning the design of these with this hard washer, it's not like the old school, like the bubble crushable washer. These are made with these new style type of, I call them hardened washers, but just made not to crush. So I'm wondering if once you get past a certain point, because of material and how it's made and stuff, that maybe just get you past, up the 10-degree past difference and not much more after that. Maybe then at that point is a breaking point. But being that we saw between 30 Newton meters and 40, both were an increase of 10 degrees, which you would have thought past 30 Newton meters you would have had more in degrees, but I'm wondering if it's because of how it's made with this non-crushable washer. And just to give you a peek or an idea again, the fuel is going to shoot down and hit on the top of the piston, and almost like a bowl, and it's an even circle all the way around. They want it to hit in there and then go out and then ramp back up. So it sprays down on the top, it'll go off to the sides, hit the wall, and come back up into the chamber head area and then be ignited. And so where they're wanting that start of the flame kernel igniting and so on is what they're trying to control by doing this, and how they designed it and where they want that flame travel going. And I guess if you don't have that correct, that's where you can get into misfires that you'll just end up chasing your tail on forever and not knowing that it was due to potentially a torquing issue or incorrect application spark plug issue facing the totally different quadrant. Okay, so I just ran test, got a capture of it at a cold start, like first cold start. So RPM's a little bit raised, and then I just cut it off. I just want to get good capture. There's that waveform, first startup, and still in the raised RPM position. And I've got some good data at that point. I didn't want it to get too warmed up, because now this, of course, is wherever the plugs are indexed at, torqued at from whoever last was in there. I'm capturing number 1 ignition in the crank sensor signal. I'm going to pull plug number 1 out. I will do reverse on the torque wrench to see if I can capture the torque rating that it's currently at, and then kind of go from there on. And then so I'll take a look and see where I want to go ahead and index it at by a certain torque range, and kind of go from there and see if there's a difference. Okay, so 23, but we are on reverse. Let's see if we can try to capture this. I have to put you down. Wow. So 37, so someone's already been in there. Okay. Since we know this was pretty much close to 40, and based on our testing we did on the cylinder head, I think I'm going to want to reinstall it at the proper one. I'll probably go 20 and see if we get a difference then. Okay, so let me share with you a little bit of what I just found out. So it looks like I sort of misspoke before, but again, this is all your first time you learning and so on and so forth. Basically, with the statement about the washer, obviously it's not going to be a true hardened steel type of washer or anything, but it's not a soft type style crush washer. But I did find out that there is some malleability in it, where it will give some now, and after it does, it'll have some memory. So what am I talking about? Basically, this is the plug out of the running vehicle. You can tell by the black portion there. I did clean off the threads a little bit. You saw me start here on the cylinder, and I was a little confused or whatever, because it was coming out towards, let's call it this quadrant, almost perpendicular. And then I noticed there was some oil and stuff in that hole, so turn the camera off, take plug out, clean the plug, the threads. Then I came to cylinder number 1. In cylinder number 1, I went ahead and torqued it to 20 Newton meters. And oddly enough, it still was in this, let's call it quadrant. That line was this guy here. These markings are from the previous test. So let's look at these short ones. So this one, this one. So I then went ahead and torqued it to the 3738, and it got me to this point. And then when measured out with the protractor, it's actually, I think it was 20 degrees. So it's 20 degrees that it went from here to here. Now it is in the same quadrant, but it did move 20 degrees. We did have a movement. Again, this is with the one that was already torqued and heat cycled everything at the 38 or so, almost 40. And it just wasn't making sense. And so I wanted to look more into it. And I went ahead to my spare bin and got another used one that looks like didn't run much, and I was hoping that at some point was not torqued crazy. So I installed this and torqued it to 20, and it faced somewhere over here. Again, it's on this quadrant. I don't know why, unless it's, no, it can't be in the head, and I'll explain why, because this plug. So then from the 20 on this, let's call it sort of known good but used, and known good meaning it doesn't look like it was torqued down crazy amount, I went ahead and torqued it to the 38 Newton meters to see if I would get the same 20 degrees. And little did I know, and I could feel that I was getting more movement. And then it went all the way up to this portion. So it was almost, I don't know, like 60 degrees, I think is what I measured. And I could tell and I could feel that I was getting more rotation. And this is from one that I'd assume when it was installed properly. But, so then that's when, if you see there the washer, this is on mine that I just crushed down to the 38, and it moved 60 degrees. And then this is the wore out washer. Look at that. From one that came out. Now this one looks like it's got a memory now, even whether it's at 20 or almost 40, it's going to land and only move that much because we've got that crushed down to almost to where it'll go, and then so you won't get much movement. If you start with, let's say, almost a virgin one, and then you end up crushing it, you will get a big increase in movement. And if you go and reuse them, that's where problems can start, because now if it was improperly torqued and then you install it, its memory's going to land it almost where it was before, and if that was the wrong spot to begin with, so on and so forth, you can start having trouble. So hopefully this keeps reiterating about proper torque and what it'll do and locate them, and now we know that they'll have some memory and reposition them where they were last torqued to. And what was confusing me is the quadrant that they're landing at. So if you remember, number 3 was the NGK from first time that was in this region. So I took that out and moved it here and torqued it to 23, and it's landing on this same quadrant as it did here. So it can't, the cylinder head is the same. The same plug lands in the same quadrant from cylinder to cylinder. And so I don't know why these are landing all the way here. I'm not going to say that they're fake or counterfeits or what, but there's something going on, because clearly this is an NGK, same part number, and it keeps landing in that quadrant. Okay, so we're going to go with 20 Newton meters and a plug that its washer does not look wore out. Okay, so we'll get this running and see if we have any difference. Okay guys, so we're going to go over the two captures that I took. And this was an area that I wanted to see out of curiosity if there was something measurable that we can see due to this, let's call it indexing situation. One quick note before we go on, the two that were locating themselves differently than the other NGK, I ended up counting, and there is one extra thread, not physical, actual, like it has more threads. There's one extra exposed thread towards the bottom, and then that is where we're getting the difference in the location. So I sat here, counted them at a same point for both, and these two, the ones that were sitting differently than that good one, do actually have one more exposed thread here. That's due to washer. And also one last side note about the spark plug. I did in my bin find an quote unquote official BMW NGK, and its part number, let's see, is the same exact one there, BRAT8S. So there's no extra dash anything or difference in the part number or down the portion down at the bottom, unlike the BMW Bosch one and the non-BMW Bosch one, where there's the extra letter, a dash S or whatever, and then how the bottom portion is different. So for some reason, Bosch, with their actual BMW labeled and non-BMW labeled, but similar, almost same part number, are a little bit different, but NGKs are the same whether it's BMW stamped or not. Okay, so as far as the captures, what I wanted to do once I started, thinking about this and people were questioning it, so on and so forth, was if I could sort of, besides the actual physical viewing of the indexing of the plugs with different torque ratings and whatnot, if past that, to further help prove out a portion of why, the whole reasoning again behind it, besides the theory that the service information tells us, is if there was something measurable. And so my idea was to capture the crankshaft sensor signal along with an ignition sync, which I'm using number 1, and see if we can see a measurable difference between the indexing of one plug to another in the same cylinder, and see if there's a difference and what the difference is. So the idea is to use a speed measurement based off of the crankshaft sensor signal, which we know is going to watch all cylinder contributions, or burn quality, we'll call it, which BMW actually states in their service information that they also use the crankshaft sensor signal for the basically burn quality, not just actual dead physical misfire, which would be easy to spot, but also for the burn quality, which would contribute to a speed difference as well as just like a misfire. But so that's what I wanted to do. This capture here is of how the vehicle came in, which at that point did not know that it was almost to 40 Newton meters. And so to sort of explain what I've got here on the screen, if you see the red line here and the red line here, red line here, red line here, that is each time ignition number 1 fires. And then this pattern here, this is a math channel created off the crankshaft signal that shows crankshaft speed acceleration. Each time you have a upward travel means a cylinder fired and contributed into accelerating the speed of the crankshaft. And so the higher it goes, the faster the speed is. And for it to continue rotating from 360 to 360, each one has to contribute and fire. Basically, keep spinning it at the same rate. This is obviously how it monitors misfires, because if one doesn't contribute, then the ramp won't go up. It'll just be stagnant or start to drop because the speed will slow down because it didn't ignite to speed it up. So, but along with that, we can try to sit here and see if there is a measurable rate of speed change in time based off of indexing. And we've got 1, 2, 3, 4 cycles here, and I did this all both before and after at a similar, pretty much same temperature, same RPM, and everything. So where I'm measuring is at the bottom peak to the top peak, and this is cylinder 1. And so the first rise after ignition 1 is going to be the contribution from that ignition point. So as soon as that starts to travel up, that's the contribution from the ignition for cylinder 1. So that's why I'm measuring there. And so the point that we are going to look at is that upward rise, and we've got it. I got those 2 points locked as far as in time measurement, and you can see there. And so we'll move to the next cycle. Again, this is all for cylinder 1. That's all what we're measuring. So there's the next cycle. There's another cycle. There's another cycle. And another cycle. So all those in time for the ramp up rate of change of speed in time is what we're measuring at 8.233. Now if we back out, that's somewhere in this point, just after the beginning. This is where we first crank the engine up. This is where it's up at high idle, and we'll measure a couple different places. So now we'll measure here towards a little bit towards the end of that waveform. There's red line again, upward travel after it. So that's cylinder 1. Bottom peak, top peak. Next cycle. Same deal. Next cycle. Here we go, same thing. Next one, same thing. And last cycle, same thing. So that's just example in two different separate areas of the waveform where we can take a measurable point. Again, with somewhere in the beginning, somewhere in the end, and off camera I've done different areas and it's all pretty much dead on the same. So this one is a capture of after we installed and torqued that different spark plug to 20 Newton meters. And so again, this is after the first start, so a little bit of the high idle. That's when it starts to come down. So we're still in the similar area as far as the RPM and stuff. Okay, so we're going to be measuring the same exact thing from the bottom peak to the top peak, you can see. And in time, look at that. So we have a measurable difference. It's less. The amount of time is less to get that crankshaft speed to raise up is less in time for that rate of change. Again, peak to peak, there's a bottom to top, cycle to cycle, measurable difference from before and after. Again, bottom peak to top peak. And I'll do the same. I'll back out a different measurable area just to help prove out a little bit. Okay, so we'll start here. So bottom, top, again the same. We'll go next cycle. Bottom to top, again. Next cycle, again. And next cycle, again, the same. So with both captures with different indexed spark plugs, obviously we don't know where it's landing, but with all that studying that we did and knowing that one came in at almost 40 Newton meters and a totally different one with a good washer at 20 Newton meters, I guarantee you it's at a totally different, probably more likable area of where BMW wants it, and you can see it on the screen in time. It's a measurable thing that we're seeing, that it changed the rate of speed, which can contribute to the way it's burning that mixture. That's the only thing we changed for the same exact cylinder. And so I think that's good enough for me to try to present this in the way that I want to see if it could be presented, other than the just putting out a YouTube short saying torque your spark plugs because the manufacturer says so, or if not, you'll have misfires. So with that, so this is why I wanted to make it, to kind of help back up some of that service information literature. Number one, I can show you physically about the clocking and indexing of the actual spark plug in the cylinder head and what it does, different torques, NICs, no NICs, the type of plug, so on and so forth. So that's number one. That's one of the important factors for torquing spark plugs on the GDI engines. Number two was the service information. I literally showed you from two manufacturers explaining and showing and telling. So you have that in paper form now, let's call it. And both gave some reasonings as to why you need to do that. And lastly, because I was trying to do research and stuff like that, I stumbled upon some papers that was explaining about the flow in spark ignition with direct injection and how it changed in time. The flow, the tumble flow and speed and everything changed in time based on the direction of where it was pointing at and when the spark happened and so on and so forth. So that gave me some sort of food for thought to try to come out here and see also physically on the car with measuring on the scope to see if we could see a difference, because we know we can capture speed through the crankshaft sensor with the math channel, and we know we can find misfires that way because the crankshaft's going to slow down. So I wanted to see if we could minutely see a difference by indexing the spark plugs differently. And we have, it's right there. And I think that's probably just the most that I can do to try to help explain as to why you should torque your spark plug. And also because of that study, the papers that are out there that I was reading about the tumble flow and how it changed in speed, that is also part of why I hope you can understand by having the plug in a different area can possibly aid in creating a misfire, because it's not going to combust properly how it was designed. The chamber's physically designed one way, the injector is designed one way to shoot in a particular direction and area. The piston top, the bowl, everything around the spark plug is not going to change unless the injector gets clogged or is not firing right for the fuel. But if everything is the same how it was designed to burn in a specific way, and then you move your spark plug to where it's not supposed to be, that's how you can get some misfires. People were telling me that no, you can't, or blah blah blah, I don't see how this is that, I don't torque them, this that. But we just saw, or you can see if it's in the wrong place and the mixture's burning incorrectly, then it's not going to accelerate the crankshaft properly, which is going to be a burn quality difference than other cylinders or from what it should be. And that's how you can create some misfires if you're not torquing them, not locating them properly. So hopefully all that makes sense. For me, I'm wiped out. This is my own free time that I'm putting in to try to help explain and better enlighten that topic that people were just having some comments with. So with that, hopefully it was informative. Hopefully you enjoyed it. Thank you for watching. Until next time, that is all for now.